Hi, in this video we are going to learn about binary frequency shift keying. It is Sridevi, Professor, Department of Electronics and Communication Engineering. On completion of this module, the students will be able to understand the basic concepts of binary frequency shift keying. Frequency shift keying, that is FSK modulation, is a form of digital modulation which is used in low cost applications. It is used for transmitting data at moderate or low level. That is in case of wireless as well as wired channels. In general, MRA FSK modulations are becoming efficiency modulation schemes. So, M is represented as 2 power n. So, M is different symbols. Every symbol use separate frequency for transmission. Such a system is called as MRA FSK system. So, several forms of MRA FSK modulations are becoming popular. So, two carrier frequencies are used here in frequency shift keying modulation. One frequency is called as Mach, and another frequency that is denoted as F2, and another frequency is noted as Mach F1. So, the generation of FSK system includes the transmitter. In this transmitter, the input is given as serial to parallel converter, followed by n-bit digital to analog converter and frequency modulator. The block diagram represents the coherent binary FSK transmitter. The binary data sequence is given as the input of on-off level encoder. This on-off level encoder is generate B of T signal. So it is divided into two parts, that is, one is upper part and another one is lower part. Upper part, this M of T is directly given as a multiplier, and lower part it is inverted by using an inverter, and the inverted signal is given as the input of another multiplier. Multiplier receives two inputs, one is M of T and the inverted M of T, which is from on-off level encoder. The another input signal of the multiplier is phi 1 of T and phi 2 of T. Let phi 1 of T be root 2 by Tb cos 2 pi FCT, and phi 2 of T be root 2 by Tb cos 2 pi F high and F low. So here both are added and the final signal is binary frequency shift keying signal. So the binary FSK transmitter, the incoming binary data sequence is applied on the off level encoder, and the output encoder is characterized by +1 volts and 0 volts. So it consists two symbols, one is 0 and 1. Symbol 1 is the upper channel and it is switched on to the oscillator frequency F1, and symbol 0 is given as a lower channel and it is inverted using one inverter, and in the lower channel it is switched to another oscillator frequency F2. So both are transmitted and it is recorded to the binary FSK signal. So input noise BPSK signal x of T, and having two phase levels phi 1 of T and phi 2 of T, and using one multiplier it is multiplied and produces FSK signal. The bandwidth of FSK signal is, before knowing the bandwidth you have to know about the limiting factor. The limiting factor is nothing but physical capabilities of the carrier non-susceptible to the noise as much as ASK. So frequency shift keying bandwidth, for 1 there will be one frequency, and for 0 there will be another frequency. So here R is equal to 1, S is equal to N, means bandwidth B equal to 1 plus D into S plus 2 DF. The application of the frequency shift keying modulation is on voice grade lines used up to 1200 bits per second, and it is for high frequency, that is 3 to 30 megahertz radio transmission. It is used as high frequencies on LAN, that use of coaxial cable, and therefore for binary FSK system has two dimensional signal space with two messages S1 of T and S2 of T. So these two signals are represented with two different levels. So the output B of T is binary data sequence that is finally obtained at the output of the transmitter. So output is the binary that is binary phase shift keying waveform. So we have one quiz question here. This bandwidth of BPSK system is dash than BFSK system is dash than BPSK. We know that always bandwidth of BFSK is higher. Always PSK is lower. So BFSK is higher than the BPSK. Thank you.